Welcome to the critique of thermal extremes, from absolute zero to Planck heat. This is a piece exploring the huge boundaries of temperature, from absolute cold to the heat of the early universe.
And human innovation, too. We were really struck by the clarity here. The comparisons are fantastic, but we do see a few key spots where we can really maximize the narrative impact.
Okay, so let's dive right in. A key theme running through this seems to be the contrast between these vast cosmic extremes and what we can actually do with human science. You make a really strong case for the highest possible temperatures with Planck heat, the absolute theoretical limit. And then you pivot immediately to the human creation of plasma at trillions of degrees.
Right, which is just an incredible number. Hundreds of thousands of times hotter than the sun's core.
Exactly. An explosive moment.
It is, but the structure of the section on extreme heat, it inadvertently diminishes one of the most dramatic physical achievements you highlight in the whole piece.
Okay, talk me through that.
So here's the weakness. By treating the creation of that trillion-degree plasma, which is the single highest temperature ever created by humanity, as just a follow-up detail right after discussing the theoretical Planck heat, the emotional and, frankly, the scientific weight of this human achievement gets a little lost. You're sacrificing a really powerful narrative opportunity to compare, human cold limits versus human hot limits.
I see what you mean. It feels less like a record and more like an asterisk next to the bigger cosmic number.
Exactly. You build up this incredible scale, and then you kind of bury the conquest.
So if we pull that human achievement out of the Planck heat discussion, do we risk losing that cosmic scale? I mean, how do we keep that contrast alive but still give the human side its proper due?
Oh, you don't lose it. In fact, I think you sharpen it by creating parallel narratives. So our suggestion is to restructure that whole heat section, create two distinct dramatic contrasts.
Okay.
First, you keep the focus on the cosmological extremes. Absolute zero versus Planck heat. That sets the stage, the boundaries of reality.
Right. The universe's playground.
Exactly. But then you create a second equally focused contrast on the limits of human technological manipulation. Think of it as the race to the extreme.
I like that. Framing it as a race is brilliant, especially since the push for extreme cold has always been talked about in those competitive terms.
It has. So for a concrete example, we think you should create a separate, dedicated section. Title it something like The Human Reach or Conquering the Scale. And this section focuses only on that comparison between how close we get to absolute zero in labs, the cold race, and the trillion-degree plasma achievement, the heat race.
So it becomes its own story.
It becomes its own heroic story. And you have to use active, vivid language. Frame that plasma creation not just as a fact, but as a conquest, a momentary, engineered apocalypse.
And how do we really make that scale land for the reader?
Well, when you describe those trillions of degrees, don't just compare to the sun's core. That's already amazing, sure. But you should actively loop back to the other temperatures used earlier.
The lava and the lightning.
The lava, the lightning, yes. Say explicitly that this plasma is hotter than tens of thousands of lightning bolts combined. Give the reader that visceral sense of scale right at that moment. It's like swinging a spotlight from the cosmic backdrop right onto the human achievement.
Okay, I love that. Using those earlier data points as anchors for the climax of the human story. That's a really powerful structural fix.
Yeah, it really helps the pacing.
So we've covered the chaos of the high heat side. Now let's switch gears to the cold. Looking closely at the section on the cold extreme, you establish absolute zero, minus 273.15 Celsius, as the theoretical limit where particles stop moving. And you mentioned the cosmic background radiation is close. It's very precise, but it feels a little static.
Exactly. Static is the perfect word. To achieve conceptual balance, the section on extreme cold needs a richer discussion of why absolute zero is fundamentally unattainable. It needs to match the dramatic depth you give to the hot side.
Right.
The weakness right now is that the cold limit reads as, just a theory. It's focused on the cessation of motion, which is a negative description. It's about what stops happening.
Whereas the hot side is about what starts happening.
Yes. The high temp side has plasma, particle accelerators, all this violent creation. The cold section lacks a specific scientific phenomenon that illustrates the unyielding physical barrier preventing us from ever reaching true zero.
That's a crucial point. Right now, it just feels like an engineering problem, like we haven't built a good enough fridge yet.
Right.
But the reality is that it's a fundamental conflict with the laws of the universe. It makes absolute zero an antagonist, not just a boundary.
Precisely. So the suggestion is to introduce a concept that shows the physical nature of that barrier, reference a specific state of matter, or a core quantum mechanical principle that elevates the Colt limit from just being a number to being this deep physical challenge.
Okay, so what would that look like in practice?
Well, for a concrete example, you could briefly bring in the concept of zero-point energy.
Ah, okay.
And frame the impossibility of reaching absolute zero not as a practical limit, but as a deep, fundamental quantum law. This idea that there's an irreducible minimum energy, that the universe itself insists that particles can never fully stop.
I like that a lot. It introduces this wonderful tension. Even when you take everything away, the quantum world still insists on a little bit of motion. That definitely gives it the intellectual weight to rival the plasma.
It does. Or if you want something maybe a little more tangible, narratively speaking, you could reference Bose-Einstein condensates, BECs, as the specific exotic state of matter we only get when we approach that extreme cold.
Ah, and that's where the balance really clicks into place.
Exactly. Think of the contrast you're setting up. The hot side is defined by plasma, the extreme of chaos, where atoms are torn apart.
And the cold side, defined by the BEC, is the extreme of perfect order, where individual atoms merge into a single quantum state.
Yes, that's it. You're using states of matter to define the boundaries of your scale, the perfect uniformity of the BEC at one end versus the total explosive randomness of plasma at the other.
That's fascinating. It anchors the reader in two very distinct, very dynamic physical realities. It's not just about numbers anymore.
Right. It turns the piece into a study of order versus chaos and shows that temperature isn't just about heat. It's about the fundamental nature of matter itself.
And that sets up our final point beautifully. We've got the extremes, the chaos and order, the human drama. Now we need to make the reader care about that tiny space in the middle where we live.
The so what?
Exactly. As I understand it from the notes, the argument is that between the cold of space and the, incomprehensible Planck heat, our reality exists in this very narrow, very specialized zone. I see what you're going for. Let's talk about how to strengthen it.
The concluding observation about humanity existing in a narrow zone is a strong idea, but it needs to be made more viscerally relevant by using the data points you already have.
Okay.
So the weakness is that the current conclusion is a little too generalized. The message that reality is broad and extreme could be so much stronger if you anchored it back to your mid-range examples, the lava, the lightning, the sun's core.
Right now, they're just serving as measurement points.
They are. They're not active components in that final existential realization. The conclusion feels like a philosophical whisper when it should be a data-driven shout.
The significance of our existence is stated, but not really felt. We need to use the data to create a sense of existential wonder, maybe even a little dread.
That's the core suggestion. Use those temperature comparisons to maximize the reader's sense of fragility, fine-tuning. You need to show that even tiny deviations inside that narrow zone are catastrophic for life.
We aren't just in a narrow zone, we're in a terrifyingly sensitive one.
That's the phrase. So how do you do it? For a concrete example, you explicitly integrate the contrast between a 1,000-degree volcanic lava, which destroys all life instantly,
Right.
and the 5,500-degree surface of the sun, which sustains all life.
Ah, I see where you're going.
You point out to the reader that the difference between immediate violent destruction and consistent gentle sustenance is just a few thousand degrees, a microscopic blip when measured against the trillions of degrees the universe has on offer.
That has the punch it needs. It's not just that we're between extremes. It's that our survival hinges on precision measured in thousands of degrees, while the cosmic scale is measured in trillions.
Exactly. So you reframe that final paragraph. Instead of just saying our existence is in a narrow range, you emphasize how terrifyingly sensitive that range is. Use the data to show that habitable existence is this tiny, fragile sliver.
And that even a small journey within that sliver, from the temperature of the sun's surface down to molten rock, is the difference between life and immediate death.
And that sharpens the so what perfectly. It moves the conclusion from a general observation to this specific data-supported statement about the miracle of our existence.
A perfect final note. Okay, so just to recap, we covered 3 key areas here, all aimed at maximizing that narrative drama and conceptual balance. First, structurally, we suggested separating the human scientific achievement of extreme heat from the cosmic limits to give it its own dramatic focus. The human reach.
Right, framed as a race to the extremes.
Then second, we suggested you enhance the conceptual weight of absolute zero by bringing in ideas like zero-point energy or Bose-Einstein condensate.
Which creates that ultimate contrast between perfect order and total chaos.
Exactly. And finally, sharpening the concluding argument by using your own comparisons, lava versus the sun's surface, to really illustrate the existential fragility of our narrow, sensitive zone of existence.
This material is already excellent. I mean, it's deeply informative, and the writing style is very engaging. These suggestions are really just about turning a robust scientific overview into a truly compelling narrative, something that leaves the reader with a profound, data-driven sense of awe and fragility.
Well said.
We really look forward to seeing the revised version of Thermal Extremes. Please submit your work back in any time for another critique.